Tribology is a scientific field which focuses on processes such as friction, wear and lubrication. Its application lies mainly in the field of bearing design, piston engines, but it also influences almost every other aspect of modern technology. The Tribology Research Group clarifies phenomena that come about during the mutual contact of two bodies. We are looking for new ways to lower the undesired friction and wear, and thereby lengthen the durability of the various parts. We focus on basic but also applied research, where we work with industries to clarify and find solutions for non-standard problems. To effectively solve friction and wear problems in this area of research, we are divided up into various sections: elasto-hydrodynamics, biotribology, and rail transport. We are one of the best research centers in the world when it comes to measuring thin lubrication films. For experimental thin lubrication film measurements, we use a tribometer based on interferometry methods. Between the rotating glass disc and the rotating steel ball, we can see a thin lubrication film forming at a certain thickness, which we are able to evaluate using optical methods. We have an NTM device to determine the value of the friction coefficient in contact. The device measures the friction of lubricated and non-lubricated contact surfaces at a wide range of kinematic, load and temperature conditions. The results are traction curves, which describe the friction value in relation to the relative sliding speed. We use the optical profilometer to evaluate the level and nature of the surface wear. The device is used for non-contact 3D measurements of surface topography. Accurate and detailed surface measurements allow us to research the effect of real-world topography or its targeted modification on the observed phenomena. Modeling processes taking place in elasto-hydrodynamic lubricated contacts allow us to compare theoretical models with experiments. Using numerical simulations, we can observe the development of the lubricant film thickness and the pressure at the point of contact. We can find friction processes in our bodies as well, such as in joint replacement. Real-world tribology hip replacement problems can be simulated on an experimental device for the analysis of friction in an artificial hip joint. The function of the device is based on the simple principle of the pendulum, where the friction coefficient between the femoral ball and the acetabular socket of the artificial replacement is given by the level of damping of the pendulum. The analysis results are then used to describe the basic mechanisms of lubrication and wear of hip replacements with a direct link to clinical research. We use the fluorescent method to verify the basic principles of the formation of lubrication films with synovial fluid and other liquids similar to biological lubricants. The method is based on the principle of fluorescent microscopy, which is applicable when it is not possible to use conventional measuring procedures. Another advantage is the option of analyzing compliant materials, which apart from poor reflectivity, are known for their low electrical conductivity, which inhibits the use of electrical methods. Rail transport plays an irreplaceable role in the transportation of people and goods. The unrelenting development in this field is conditioned by the increase in safety, ecology and noise standards. Our group is not one to fall behind in this, and it focuses mainly on researching wheel and track contact and its related adhesion. One of the devices used for applied research is the twin disc machine, which is used to simulate real operating conditions at the head of wheel and track contact. Thanks to the testing chamber, we can simulate various conditions such as rain, various temperatures and track debris. Another device is used to simulate the contact between wheel and track the track in real geometry. This device is mainly used when studying the process of lubricating wheel flange. For the given parameters of lubrication application to a flange, it is possible to determine the friction coefficient and the wearing of a rail track sample. Moreover, the optical system can be used to visualize the distribution of the lubrication layer at the contact area. This video was made within project Popularization of Brno University of Technology R&D results and supports systematic collaboration with Czech students. Registration number CZ1.07/2.3.00/35.0004. Co-financed by the European Social Fund and the national budget of the Czech Republic.